Solar furnace. A solar furnace is an instrument to heat high temperatures by concentrating solar radiation on a specimen. The solar furnace have been used for the scientific investigation. The first scientist, the French scientist, is investigated in 1774. He is invented. After that, in 1921, a German scientist, some of the modified in the solar furnace is included as a parabolic, concentrated, and lens to be modified in the latter. He is modified, so it has a used for the high temperature purpose. For that figure shows that for solar furnace arrangement are shown in a figure. The solar furnace is arranged as number of heliostat in is traced on a sloping surface, so it regards the sun portion is always reflected to the solar radiation, that is having this a number of arrangement to be tracking in the parabolic systems. The collector then bring a solar radiation in focus within a small volume of the receiver. In a figure, the heliostat type of furnace with the horizontal optical as shown shows to be here is conveniently widely used for this large furnace. The most desirable mirror is obtained by the grading and polishing as a glass plated into an optical plate, or otherwise it is using as aluminized or silvering by the vacuum evaporation and the cooling with the suitable fluids. The change of evaluation that can be uh, that the change of evaluation that of azimuth can be obtained by the radiation of a frame about a horizontal axis and about a vertical axis respectively, in order to rotate the frame using a hydraulic or electrical device to be used, which is coupled with the servo system. The following based on the sun tracking system, tracking system. So other methods is used many heliostats convey the solar radiation into concentrators. So that is a use of solar radiation. The solar use of the solar furnace is an excellent mean for studying the property of ceramics and high temperature above the range of uh, high temperatures above the range of to be measure the laboratory with the fluids and electrical currents. So if you use as a physical measurement including a melting point, phase changes, specific heat, or otherwise a thermal expansion or thermal condension, magnetic suspectively, and thermonic emissions. The several useful of metallurgical and chemical operations have been carried out at a high temperature of in a solar furnace. The melting and sintering of temperature of ceramic, such as zygronic, easily utilized. The some of the advantages of the solar furnace. So the solar furnace, that is heating is carried out without any contamination, and the temperature easily controlled by changing the position of the materials in focus. It gives an extremely high temperatures. It provide very heating and coolings. The uh, various property measurement means that is a possible for open specimen, and it is used to uh, contamination by ions does not occur the fusion which may happen to for the plasma or oxygen flame. So another one thing, that is a proper disable atmospheric can be provided in a specific in the specimen. So some of the disadvantages are limited means. So it is used to limited sun days, for example 4 to 5 hours only for maximum bright in a bright suns only it have been used. So another one is it have taken as a high cost compared to the high cost. Now we will discuss on the solar cooker. In our country, energy is consumed for cooking, so majority of portion of the total energy consumed per the year. Variety of fuel like kerosene, cooking gas, firewood, dung, and agriculture waste are used. the energy crisis is affecting everyone. The poor developing countries who have been using dry wood picked from the fields and forests as domestic fuels have been affected in their own way due to the scarcity of the domestic fuel in the rural area. At present, the firewood and cow dung cakes are most important source of the fuel for cook the food. The cow dung is precious to be allowed is used for burning and cooking, but it is very useful to improve the fertility of soils. It should be used in a proper way. So now generally the solar cooker have a very relevant places in the present fuel consumption pattern. So the various design of solar cooker have been developed in our country. The first solar cooker was developed in 1947 by Mr. M.K. Ghosh of Jamshedpur freedom fighter. He has developed a box type solar cooker with a reflecting mirror and a copper coil inside, which is the food material used to place in a pot. So after that is later in 1953, NPL of India developed a parabolic solar cooker. And the main source of non-acceptance of this device was cheap availability for cooking the fuel during these days. So the problems of harnessing and utilization of solar energy arose after the fuel crisis in 1970, which also affect the rural area. So the basically three type of designs of solar cooker we are used. So the first one is a flat plate box type without reflectors, and flat plate box with reflectors and parabolic disc concentrators. So that is a flat plate design is the simplest all the design. The maximum no load temperatures with a single reflectors, otherwise without reflectors, up to 160 degree Celsius. So the multi reflectors are one oven, a 4 square as a rectangular reflectors mounted on a oven body. They have reflected ratio into a cooking zone, with the cooking as used as a stainless steel or placed. The temperature is obtained at 200 degrees Celsius. The maximum temperature can be reached 250 degrees Celsius. If compound cone reflector system is used with the parabolic disc concentrated type of solar cooker, the up to the temperature is raised for the 450 can be obtained with the solar radiation and concentrates on a focal point. So now I discussed on the solar cooker for that solar cooker of that is a flat plate solar cookers. Principle and construction details of the flatbed cookers. The principle of the solar rays penetrated through the glass covers and absorbed by the blackened metals tray kept inside the solar box. The solar radiation entering in the box of a short wavelength. If the higher wavelength radiation is not able to pass through the glass covers, the two glass covers provided to again minimize the heat losses. The heat loss due to the convection is minimized by the making of metal box with air tight by providing by rubber strip of all around between the upper lid and the box. So the insulated material like glass wool or paddy, husk or sawdust or any other material is filled within a space between the blackened tray and the outer surface of the cover box. So the minimize the heat loss due to the conduction. With this type of cooker is placed in the sun blackened surface started absorbing the sun rays and temperature inside the box to be start rising. The cooking pot are also blackened placed as a blackened plate placed will get heat energy and food be cooked with a certain period of time depending upon the actual temperature attained the inside. It based on the solar radiation or the temperature attained depends on the intensity of solar radiation and material of insulation is provided. The amount of solar radiation intensity can be increased to provide by the mirrors. We can use as a mirror. The amount of solar radiation intensity can be increased by inner and outer metal of the wooden box with double glass sheet. The observer tray and painted with black suitable paint like as a galvanized nickel chrome as a nickel chrome. The top cover contain has two plain glasses that is a 3 mm thickness. It will be taking as a gap between the 20 distance between the two grasses. The entire top cover made tightened with the uh, padlock halves. So the collector area of solar cooker is increased by providing a plane reflecting mirror equal to the size of the box and hinged with the one side of the glass films. So the mechanism is provided to adjust the reflector at a different angle. At 15 to 25 degree rises the temperature achieved in the inside box when the reflector is adjusted to reflect the sun rays into the box. So during the winter, when the sun rays are is much inclined to a horizontal surface, the reflector is most useful for the addition. So normally it will be dimension have within 60 60 centimeter, and depth is 60 centimeters, and width is 60, length is 60, and height for 20 centimeter. This type of cookers, the family used for the family small family cookers, so it will be sufficient for 5 to 7 peoples. The temperature inside the cooker is single reflectors maintain about 70 to 110 degree above the ambient temperatures. The temperature is maintained food slowly and steadily and surely delicious with the prevention of nutrients. So the maximum temperature of inside the cooker is 140 degrees Celsius at 140 to 160 degrees Celsius during the summer season. So depending upon the factors such season, a day, the type of food depend upon the food layer, type of cooking, it will be varied for 1 to 4 hours it be used. So some of the advantages of the cooker, solar cookers: no attention is need for cooking is other device, no fuel is required, less maintenance cost, and no pollutions. So and vitamins of food no destroyed means that is and food and cook is nutrient and delicious with natural taste. So no problem for charging of food or otherwise no overflowing. So some of the limitation is depend upon the sunshine means that is it have cooking according to the sunshine. The menu has pre-planned. So once one you can not cook for short notice or otherwise it food cannot be cooked at a night time during the cloudy days. So it can be comparatively more time to prepare the preparation of food for the cooking. So now we have discussed on the solar thermal electric conversion system. In a solar thermal power production system, the energy is first collected by using a solar pond and flat plate collectors or otherwise focusing collectors. So the energy is used to increase the internal energy. Energy is used to increase to temperature of the fluids. The fluid may be directly using any common known cycle such as Rankine or Brayton cycle or Stirling cycles. So or other passing through the heat exchanger to heat as a secondary fluid which is being used in a cycle to produce the mechanical power from the electrical power can be produced easily. So the following four system can be used for thermal electric conversion system. So low temperature cycle using flat plate collectors or a solar pond. Second one is a concentrating collector for medium and high temperature cycles, and power tower concept for central receiver system, and a distributed collector system. So there is a four different type of system to be converted by the thermal electric conversion system to be used. So now I have seen that is a low temperature cycle using as a solar pond. So the flat plate collectors uh, and the solar pond are classified low temperature collector because temperature is achieved order of 60 to 100 degrees Celsius, and the collection efficiency is 30 to 50 degree. So if the Rankine cycle solar thermal power production is employed in since temperatures about 100 degrees Celsius, the maximum temperature limited for 80 degree. It's not as a possible to generate the steam with the flat plate collectors. So it can be used directly prime. It cannot be used for directly flame over. So therefore, some of the other organic fluid for used in the system, the temperature of the high pressure are absorbing the heat energy heated from the water. And the vapor is formed can be used to run the turbine or engine, which may generate the power which will be sufficiently to light the group of house for rural area for irrigation purpose. To convert the solar energy into electric through a thermal conversion and reaches has that is a considerable work in varying capacity of power system. So the organic fluid cycle can be extensively used for these studies. The development work generation of the thermal power system has up to that is a 10 kilowatt and up to maximum it will be having a 15 kilowatt to be used. So here that is a shows that is a solar plant with a low temperature system. So the solar plant low temperature system generally used for the electric power productions. So it have consist of a one solar plant. So having that is a one of the evaporators and the turbine and condenser is the condenser and cooling tower system to be used for the system. The thermal energies from the solar plant usually used to drive the Rankine cycle of heat engines. So hot water from the bottom of the solar plant, uh, pumped into the evaporators. And the organic fluid is vaporized in the evaporator. And having the organic fluid to be vaporized by using this, utilizing this heat from this liquid, the evaporator, the vapor flows under the high pressure and entered into the turbine. They expand in the turbine. The organic fluid is expanded in the turbine. That is a form as a vapor form expand in a turbine. That the turbine expand the turbine and send to the condenser. That vapors to be condenser. So after that condenser is used to return into the condense, that is a liquid vapor organic fluid and pumped again liquid into the evaporators. So that is a cooling device is used to waters. So the hot water is cold water to be entered to a condenser and the condenser the vapor. The hot water again goes to the using as a cooling tower. Recycling the cooling tower can be recycles. So that used for this system, that is a generator is coupled with the generators. So it will be produced as the electric powers. So it requires for that maximum power to be produced at maximum 10 kilowatt power generation to be produced. So next one is that is a low temperature cycle using as a flat plate collectors. So it required for solar collectors are used for that maximum it will be having a large areas required. So it will be attain maximum the flat plate collectors attain the maximum temperature is 75-degree temperatures. So the here we are using as a high pressure butane vapor organic fluids can be used. High pressure butane vapor can be used. So that is a solar the solar radiation here the water is circulated to the water system. So the water heated solar radiation absorbed by the collectors. So the water is converted rising the temperature up to the 70-degree to 80-degree temperatures. So that is the evaporator like as a butane boiler we are says as a heat exchanger or otherwise a butane boilers. So the butane can be converted into vapor. Then the vapor is sent to a turbine. The vapor is expanded in a turbine. It will be connected with a pump or generator. Otherwise, using as a pump or generators like as a solar pump system working as a solar pump system. So here also we have connected with the generators. If you produce as a electric power system, electric generation, or otherwise it will be goes to the condenser. That is a vapor again goes to the condenser. It will be the condenser it used to condensate the butane vapors again pumped into the heat exchangers. So the cycle is repeated to the heat is transferred from the hot waters and cycle is repeated to the producing of powers or otherwise it will be using as a pumping system to be used. So the maximum power to be produced for up to 20 kilowatt using this system by the low temperature cycle using the flat plate collectors. So next one is that medium temperature cycle that's using of concentrating collectors. So the system generally employs arrays of parabolic parabolic concentrator trough collectors system we are used, which it gives the temperatures above 100-degree. So the general range of temperatures as 250 to 500 degrees Celsius. So a simple parabolic trough collectors is already known, that is a working principle you have known that one thing. So they just have the solar radiation absorbed from the trough, absorb the trough area. So it is coated with aluminum or a mirror strip to be placed. So this is the observer plate, the observer tube. This is center focal point. So radiation to be absorbed and reflected to the focal point of the radiations. So it will be taking converted as a high temperatures, has it consists of a parabolic cylindrical reflector. It is selective coating suitable material to be pipe minimize the infrared radiation. So it have proper subtracking arrangement to be used for chain or chain drive or chain link to be change over the direction of the regarding the sunlight temperatures. So it will be attain the maximum temperature up to 500 degrees temperatures. We can use directly into without of organic compound. We can use directly to produce the energy power turbines with coupled with the turbine and produce the generators, sorry, electrical energy by using of a generators. So the next one is having that is a uh, high temperatures, that is a high temperature system. It is used for high temperature system for efficient conversion of heat energy into mechanical energy. Since have in the electrical city, the working fluid should be supplied to a turbine at high temperature. The such temperatures is about 180 degrees Celsius to 190 degree Celsius from the solar energy required. So focusing or concentrating collectors, since it have used for direct solar radiation, but essentially no diffuse radiations, most effective for the locations. So the two basic system is used for this system. One is a central receiver system, another one is a distributed system. Here that is a central source as a central receiver system for the to be shown to be here the figure. So in the system already we have solar radiation is focused in the central receiver, that is a using of heliostat we have already discussed. So once again I repeated, that is a number of heliostat to be fitted. The heliostat will be reflected mirror, that is a concave mirror. So sun rays are heated in the mirrors and reflected to the center of the center of the body. It have a long towers, so it have consists of a with a certain height. So number of heliostats to be around the entire surrounding with the central towers. So the mirrors are insulated with a ground and oriented to the reflected direct beam radiation and observe the receivers which is mounted on the top of the tower located at the center field of the mirror to produce the high temperatures. This is possible position to the boiler view of all the mirrors. Um, in the beam radiation incident on a boiler, observe the track of pipes. Observe the track of pipes. The working fluid allowed to drive the turbines. The heated fluids entered into the here. That is a heated fluid entered into the turbine. So turbine will be rotated. Again, that is a recirculated into the recirculated. The turbine will be rotated and recirculated into the cooled fluid will be sent to the upper portions. So working fluid allowed to the turbine produce the mechanical energy. So the turbine is coupled with alternators. So the main thermodynamic convection, the heat sink is provided. That is a the suitable heat storage is also provided to supply the heat for the during the cloudy days and other some days to be used for the system. That is a heat sink system. It is used for store the energy, heat energies to be stored. So then it will be used sent into the recirculating, that is central tower of the system. So again recirculated by using this power, that is a electrical generator to connect it. It will be produce the electrical energy. So this is a concentrating collector for high temperature system. So that is for that.